Hi class, how are you today? Oh, I'm sorry to hear that. Anyway, our learning target today is to be able to transform shapes using translation. So we'll be moving a whole bunch of shapes from one area to another, and that's known as translations, which we'll talk about in just a moment. So now we've finished Unit 1, which was constructions, and now we're into Unit 2, transformations. We'll be dealing with a few different kinds of transformations, including translations, which is physically moving shapes from one spot to another, rotations, which is rotating an object, changing its orientation, whether the top point is moved to 180 degrees or 90 degrees or 360 degrees, just moved in a circle but not physically moving where it is. Reflections, which is taking an object and reflecting it over a line, very similar to what a mirror does, or if you remember, the mirror. And composite transformations, which is taking all of these kinds of transformations and combining them into one big transformation. There's also another kind of transformation, which is known as dilation, but we won't be doing that in this unit. We'll see it later on, a couple units from now. Today, though, we're just going to talk about translations, and we're going to be moving objects, as I mentioned before in the learning target. To start off, we're going to look at some vocabulary about translations and transformations in general. The first word is preimage. This is the original figure prior to a transformation. So it's whatever you start off with before you do any transformations at all. The next word is image. This is what the figure looks like after the transformation. So after you do whatever transformation you do, this will be your final object. This will be what your object looks like. Translation vector is a ray that defines the magnitude by its length and direction of the transformation. So this will be the thing that tells us where to move the object to. Next, there are a couple properties of translations. The first being that the preimage and the image are always congruent. So that means the object that you start with and the object that you end with are exactly the same except for their position. They're just moved, but they're the exact same object. And the second property is that line segments linking a vertex of the preimage and the same vertex of the image are congruent and parallel to each other. That means the translation vector at each vertex is congruent and parallel to every other translation vector from every other vertex. We'll talk more about those once we start drawing them. Now for some actual examples. Let's look at this graph here. We have two shapes. We have a brown triangle and a blue triangle. The brown triangle is what we'll call our preimage. That's the one that has not been transformed yet. So we'll call that triangle ABC, and it is translated to become the blue triangle, so it's just moved. To show that it's been moved, we'll show our translation vectors. Notice that the translation vectors all have the same slope and length, as I mentioned before in the translation properties. So the translation vectors, they all go over 5 and down 1. So from each vertex, they bring a corresponding vertex and create the image triangle. Since this new triangle is the image, its vertices will be known as A prime, B prime, and C prime, with little apostrophes being noted as prime. So you can tell which one is the preimage and which one is the image, because the image will always have the prime marks. For this example, we're going to transform triangle ABC using the transformation rule that they give us. And in this case, they say xy transforms to x minus 6, y plus 2. What that means is, for every point on that shape, we will move horizontally to the left 6 units, because it's negative 6, so we'll move to the negative side. So we'll move left 6 units and up 2 units because it's plus 2. So remember, x is horizontal movement, y is vertical movement. So if you look at point A, that is currently at the point 8, 8. Point B is currently at the point 10, 6. And C is currently at the point 2, 2. So we'll throw these down here so we can see A is the point 8, 8. B is the point 10, 6. And C is the point 2, 2. So now what we want to find is our A prime, our B prime, and our C prime, the images. So to do that, we look back up at the transformation rule and we see x minus 6 and y plus 2. So for point A, we have 8 minus 6 is 2, and 8 plus 2 is 10. For B prime, 10 minus 6 is 4, and 6 plus 2 is 8. And for C prime, 2 minus 6 is negative 4, and 2 plus 2 is 4. So now we plot those on our graph to make our image. So we plot those 3 points and then draw our triangle. And now we have our translated triangle. See, it looks exactly the same, but it's just moved. And finally, we'll label our point A prime, B prime, and C prime. So for the next example, they want you to look at the translation that's happening. They show you a triangle ABC, and then a triangle A prime, B prime, and C prime, and they want you to figure out what is the rule. So remember, the rule is shown xy, and then with an arrow, and you have to say what the rule is. So to start this, let's write down what points we have. So we have A is the point 2, 1, B is the point negative 6, 4, and C is the point negative 3, negative 2. And then our translated triangle, our image, is A prime, which is the point 6, negative 2, B prime, which is negative 2, 1, and C prime, which is 1, negative 5. So if you look at the x-coordinates on each of these, for A, we have 2 to 6. Well, to get from 2 to 6, you have to add 4. Let's make sure it works on the other ones too. Negative 6 plus 4 is negative 2. Negative 3 plus 4 is 1. So that means we add 4 to the x. So x becomes x plus 4. And then for the y, let's look at the y's. We have 1 to negative 2. To get that, you have to subtract 3. 4 minus 3 is 1. Negative 2 minus 3 is negative 5. So for the y's, we will subtract 3. And there we go. There's our rule. x becomes x plus 4, and y becomes y minus 3. In this final example, we have triangle A prime, B prime, C prime is the image from translation rule xy into x plus 7, y minus 4, and it wants you to find the preimage. What that means is what we are given now is the image. We're given it after it's been translated, and it wants us to find the original image, the preimage. What did it look like beforehand, before the transformation? So we see that A prime is the point 2, negative 2. B prime is the point 2, negative 4. And C prime is the point 5, negative 3. So using that and the translation rule, we want to find what the original preimage was. So we want to find what was A, what was B, and what was C. So the translation was to add 7 from the preimage, the x-coordinate, to get the image. So if we look here, A prime, its x-coordinate was 2. So if we do the opposite and subtract 7, we'll find out what 7 was added to get 2. So 2 minus 7 will give us negative 5. And then we see here that A prime was negative 2 for the y-coordinate, and we had a y minus 4, so that means we do the opposite and add 4. So that'll give us 2. And we do the same thing. We're just doing the opposite of what happened. So B prime was 2, so subtract 7 to get negative 5. And B prime y-coordinate was negative 4. Add 4 to get 0. And for C prime was 5, so subtract 7 to get negative 2. And the y-coordinate was negative 3. Add 4 to get 1. And we have our coordinates. And all you would have to do after here is just plot the points and make your final triangle. That's it for my lesson today. I'll be sure to see you in class next time. Please, please, please don't forget to take notes on this, because that's what you're graded on. So take notes, and I will see you next class. Have a good night.